So let's take a look at this function, this f of x function. That's a quartic, to start talking about a bit of new vocabulary. Some of it you've already heard of. The first question I'm going to ask is, when is the function increasing? So when is it rising? So if I start here and start to go up, I think you can see that it'll be increasing starting at x equals 2 and going to infinity. So in interval notation, it's increasing between 2 and infinity. It's also increasing in this little section here, so that's between -1 and 0. On the flip side, when is it decreasing or when is it falling? It's falling between -infinity and -1. This here is at -1, and then again between 0 and 2. Now, this point here is approximately to -27, but is it 2.1? Is it 1.9? That's hard to tell based on this graph, and so we're going to be using some algebra and calculus derivatives to find out exactly the intervals of increasing, decreasing. Using a graph, you're just going to be getting an estimate. What I also want you to understand is that in these areas that are red, if I draw tangent lines to the curve, they are all negative. So that means if I plot -1 on the number line, the derivative is negative between -infinity and -1. And then it makes another change at 0. And it's positive in this area because the slope of the tangent line is positive. And then it makes another change at 2. And between 0 and 2, it's going down, so it's negative. And then the last tail end, it's going back up again. So I'm using a number line here as an introduction because it's a tool we're going to be using later on in the lesson. The last thing that I wanted to talk about here is the places where it makes the switch. So here, this is where the derivative is 0. Horizontal tangent line, same thing here. And these two, and a third one here. So there are 3 horizontal tangent lines. So there are 3 places where the derivative is 0, one at x equals -1, one at x equals 0, and the third one at x equals 2. And all of these are called critical points. So let's analyze this again, a different function, a little bit odder shape, and it would be hard to predict what the equation of this one looks like. But where is the derivative positive? So in other words, where is it increasing? Where is the slope going up? And I can see that the tangent line here is positive, so it's going up between here and here. So it looks like approximately between 0 and 4. Where is it going, function going down? That's another way of saying where is the derivative negative. So notice this tangent line, if I was to draw a tangent line, they're all negative here. So the intervals that the derivative is negative is from -infinity to 0, and then again from 4 to infinity. Now, right here, it looks like the tangent line is vertical. So the derivative does not exist at x equals 6. And the derivative does not exist at x equals 0 either. This one, because it's a vertical tangent line, goes vertical, and this one is because it's got a sharp corner, and we've talked about that in previous lessons before. Now, if I was to draw a sketch of what the derivative looks like, I would put where my derivative doesn't exist, or where it doesn't exist and where it's 0 on a number line, and then plot what happens to f prime of x, whereas the slope is negative in here, positive here, negative here, and negative here. And that means it's going down, up, down, down. And when you switch from going down to going up, it means there is a min at x equals 0, and this one is a max at x equals 4. There is no change in the derivative going from here to here. It just continues to go down, so there is no max or min at 6.